I decided to choose a study called The Metabolic and Performance Effects of Caffeine Compared to Coffee During Endurance Exercises. I just kind of randomly drew, saw this article when going through Instagram, and I was kind of struggling on what I should do for exercise fizz, and this just seemed to work out alright, so I just chose it because it seemed interesting because I like to drink coffee. Um, so in the introduction, they talked about how in previous studies, caffeine has been um, kind of shown to improve performance for submax and high intensity performance. Some of the proposed mechanisms for previous studies are that the increase in fat oxidation leads to an increased sympathetic nervous system response, um, improves muscle glycogen sparsity. More recently, as an adenosine receptor agonist, which helps to activate the central nervous system that decreases the pain and exertion perceptions. It probably just allows them to push a little harder when they would typically feel sore because it's kind of overriding what the central nervous system would tell them to kind of slow down. The peripheral nervous system increases with this as well. If you can improve your motor recruitment um, and contraction coupling, that only aids in um, how strong and how quick that you can get to some of these time trials and stuff that they use as their tests in the studies. Some of the previous studies that I haven't studied much of the effects on just coffee um, on performance at different dosages and things like that. Um, Most of the caffeine studies are either through pills that were ingested or that are dissolved in water, and with the caffeinated coffee with just caffeine dissolved in it to kind of give it the coffee taste, I guess. And then the authors stated in this study that the aim of it was that acute coffee intake and anhydrous caffeine are ergogenic to cycling performance compared to decaffeinated coffee or placebo beverages when using a validated 45-minute time trial performance test. They use 8 subjects for this. They were trained cyclists or triathletes. The average age was 41, 1.8 meters high, tall, around 79 kilograms in weight and mass. And their average VO2 was 58 milliliters of oxygen per kilogram per minute. Um, in order to be included into the study, you had to be training 3 times a week for greater than 90 minutes per session for over 2 years total. And you're just going to be drinking coffee all the time. They didn't really define what normal caffeine intake is. They just said low habitual caffeine intake. They use a single blinded crossover randomized counterbalance study. They didn't blind the researchers who were given the beverages, but they blinded the participants to what kind of beverage they were going to be receiving. They did 4 different experimental trials that were separated by 7 days each, with 4 different beverages consumed on those 4 different experimental trials, either caffeine coffee, decaffeinated coffee, or placebo. They consumed the beverage an hour before performing a 30-minute steady state cycle exercise bout at 55% VO2 max. And then after this, they did a time trial for about 45 minutes, which I'll discuss later. In the preliminary trial, they had 2 of them. This was just to find the watt max percentage for each participant. 2 trials, 7 days apart. They used an incremental exercise test on a cycle ergometer. They would do a 5-minute warm up at 75 watts, and then they would start the trial. Started at 95 watts for 3 minutes, and then every 3 minutes increase the wattage by 35 watts until voluntary exhaustion. During the experimental trial, they had a catheter in their elbow, which took all the blood sampling. Then they would get set up for that. Then they would consume the beverage, and then they just said they'd hang out for an hour, just kind of let everything settle in and digest and get through the bloodstream, I suppose is why they would rest an hour. Then they do the 30-minute steady state at 50% of their watt max during that time, and they would collect the respiratory breath samples to get VO2 max and compare that at the end. after the 30-minute steady state, they had about a 1 minute rest, and then they're just instructed to complete the target work at 70% watt max in the quickest time possible. They didn't give them any feedback on how they're doing with their times after each trial. Um, the beverages were the caffeine was anhydrous caffeine, which they said in the paper was 99.8% pure, dissolved in 600 milliliters of water, which all of these were all dissolved in 600 milliliters of water, and it was all hot water, so you wouldn't know which one was which. The instant coffee was at 5 milligrams of caffeine per kilogram of body weight. They had decaf coffee, which is instant decaf coffee, and then they had a placebo of 8 milligrams of quinine sulfate, which just gives it a bitter taste to water. And they served them all in an opaque sports drink bottle, so they wouldn't be able to tell which one was which by color. I did pretty brief results. Some of the graphs were kind of complicated with adding in all the different kind of stuff that they try to track in the blood. And some of the VO2 and heart rate stuff wasn't very significant either. But the main results were that caffeine and coffee had a significant better finishing times compared to both decaf and placebo. But when you compare just the two, the caffeine and coffee, there wasn't a significant difference in finishing time. When they compare to the literature, it's kind of consistent that previously caffeine is superior to decaf and placebo, whether it's just caffeine dissolved in water or coffee. The thing unique in this study is that caffeine and coffee had no significant difference when compared to each other. The authors in this study try to claim that this is the first study to show that when ingested an hour before exercise at higher caffeine dose, at 5 milligrams, some of the other studies use 4.5 milligrams, that coffee is equal to caffeine to improve endurance exercise performance. Before, coffee was thought to impair the ergogenic effects due to the chlorogenic acids. They measured in the study with all the blood sampling they did. I didn't feel like it that complicated with this paper, so I didn't really go into all the details in that, or else I could be talking about this for 20 minutes. It's not likely that the mechanisms from fat oxidation, as this was measured during the steady state when there's no differences for that, which was stated in the intro before as a possible mechanism. Observed a significant increase in plasma glucose, folic acid, and glycerol concentration following caffeine, which kind of helps support the adenosine receptor antagonism after caffeine. But the study does not support the idea before that the chlorogenic acids in coffee impair ergogenic effects of caffeine. And some of the limitations of the study were that chlorogenic acid content of coffee was different compared to most. I thought it was a minor limitation. Lower doses are more applicable and realistic. Then overall, yeah, that's my paper. Thank you.